Oh Lord, look at that line. So completing the square. So we have quadratic equation that we could use to solve. We have the square root method. We have factoring. And sometimes if neither of those work nicely, you can also complete the square, which is a lot of pretending. So in this case, to complete the square, since this is not a perfect square, if I factored this, I would have 5 and 2 for the factors of 10, or 10 and 1, and that's no way for me to get an 8 in the middle. So I pretend, which I'm okay with pretending. I take the 10 over to the other side. And then I pretend that it is a perfect square. So if it's a perfect square, half of the 8 is 4. And then 4 squared is 16. The pretend part comes here. If it was a perfect square, it would be this. And now 4 times 4, which is 16. And then 4x plus 4x would give me my 8x. So now I'm going to add 16 to both sides. And 16 is what the end part of the perfect square would be. So I have x plus 4 squared. I'm adding 16 here, adding 16 here. Okay. So I have equals 6. So now I can do the square root method because I have a perfect square on the left side and the right side. So I take the square root of x plus 4 squared and the square root of 6, which leaves me with x plus 4 equals the square root of 6. This is really plus or minus, but minus 4 minus 4. So I have x equals square root of 6 minus 4. And then x equals minus the square root of 6 minus 4. Maybe I should write it that way. I want to write it this way. Minus 4 plus square root of 6 and minus 4 minus the square root of 6. Not sure if it matters, but I kind of like to see the square root thing at the end part. Okay, so let's do x squared minus 6x equals 12. I'm just going to give myself some space. Complete the square. So half of 6 is 3, and then 3 squared is 9. So I'm going to add 9 to both sides. So I have x squared minus 6x plus 9 equals 12 plus 9, 21. I can factor this. to a perfect square. X minus 3, x minus 3. That gives me the 6x in the middle. Minus 3x and minus 3x, which gives me the minus 6x in the middle. So I have x minus 3 squared equals 21. Now I can take the square root of both sides. So I have x minus 3, he comes out of the square root sign, equals the square root of 21. And this is really plus or minus. So my two answers are going to be x equals 3 plus the square root of 21, and x equals 3 minus the square root of 21. So I have two answers because I started with a quadratic. X squared plus 5x minus 1 equals 0. Okay, no way for us to factor 1 and get a middle term of 5. So I'm going to complete the square. For me to do that, I move this 1 first because he's in the way. So I have x squared plus 5x plus 1 plus equals 1. Ew. Complete the square. It's not going to be nice, but half of 5. So 5 over 2. And then square that is 25 over 4. So I'm going to add 25 over 4 to both sides. It's disgusting. One over 1 is the same as 4 over 4. So 29 over 4. Okay, so the square root, no, factor this. Two. Equals 29 over 4. So now I can take the square root of both sides. Leaves me with x plus 5 over 2 equals the square root of 29 over 4. Which is the square root of 29 over the square root of 4, which is the square root of 29 over 2. Now I can subtract 5 over 2. This is really plus or minus. Beginning to do that. So my two answers are, and I like to have the square root 1 at the end. So 1x equals minus 5 over 2 plus square root of 29 over 2. and minus 5/2 minus the square root of 29/2, which I'm going to rewrite nicely. X equals minus 5 plus square root of 29 all over 2. And x equals minus 5 minus the square root of 29 all over 2. Four x squared plus 16x minus 9 equals 0. Not every time you're going to have the leading coefficient or the number in front of the x squared to be a 1, because life just isn't that easy. It's just when it's not, you just have to be more careful when you're adding and completing the square. I'm going to take the 9 over, so I can be left with just this partial equation. And now I can complete the square. I would do half of 16, which is 8, squared. So I'm trying to add 64. But since I have this 4 here, I need to be careful. Let me see. If I did the add 64 thing, I'd have, 2x. 2x plus 8. 2x plus 8. And my middle would be a large. My middle is going to be twice what I need it to be. This is going to give me 32x and I need 16x. So I'm going to cut this in half. And see if that helps. 2x plus 4. X plus 4. This gives me 8x and 8x. And my middle is 16x. Okay, so usually for the other ones, when you had the first number was 1, you would just take half of the middle term, square it, and add that. But since now I'm doubling each of those things that I multiply to get the middle term, I have to take another half. Be careful. Okay, so now I'm working with 2x plus 4 squared. And I'd be adding 16. So I'm adding 16 to both sides. I need to add 16 to this side, but I need to add to that side. So now I have 2x plus 4 squared equals 25. I can take the square root of both sides. I have 2x plus 4 equals the square root of 25 is plus or minus 5. So 2x equals minus 9 and 2x equals 1. I did 1 was plus 5 minus 4. That's my 1. And the other one I did minus 5 minus 4. I got minus 9. So now I'll divide both of those sides by 2. One answer is x equals minus 9 over 2. And my other answer is x equal 1/2. X squared minus 4x minus 5 equals. I'm going to take the 5 to the other side. 2x squared minus 4x equals 5. I'm going to divide by 2 because there's no way for me to get a perfect square with just a 2 with a 2x squared. I'm going to divide both of these terms by 2 and this term by 2. Yuckaroo. Everything by 2, divide by 2. So now I have x squared minus 2x equals 5 over 2. Complete the square. Squared minus 2x. Half of 2 is 1, and 1 squared is 1. So I'm going to add 1 here and add 1 here. And instead of just 1, I'm going to put 1 over 1. And since my denominator here is 2, I'll use 2 over 2. Try to make it as nice as possible before I start doing all this square stuff. So now I have 7 over 2. And here I have x minus 1 times x minus 1, because that is going to give me my minus 2x in the middle, in my middle term. I can take the square root of x minus 1 squared and the square root of 7 over 2. Leaves me with one of the x minus 1 terms equals the square root of 7 over the square root of 2. This is a lot of work. Now, because I have a square root in my denominator, I have to rationalize it and multiply by whatever my problem is, by the square root of 2. And I have 7 times 2, 14, square root of 14, over just 2. This is plus or minus. I remember this time. So my two answers for x will be, I like to switch it number. So x equals 1 plus the square root of 14 over 2, and 1 minus the square root of 14 over 2. So I'm going to make this also a fraction that is 2 over 2. Over 2. So now my x is 2 plus the square root of 14 all over 2. And 2 minus the square root of 14 all over 2. X equals. And two answers. Yeah. I don't know why I thought this would have been nicer, but Squared minus 8x plus 21 equals 0. Okay, no way for us to get an 8x as a middle term because 7 and 3 to give me 21 or 21 and 1. No way it's going to give me an 8 in the middle. So I'm going to do the complete the square. Move the 21 to the other side. X squared minus 8x equals minus 21. Okay, so now life is good again, and I have the invisible 1 in front of the x squared. So I don't need to multiply or divide or do all that business to figure out what my term will be. I just take half of 8 is 4. I square that. And then I add it to this side. So x minus x minus 4 and x minus 4. 21 minus 5. Minus 16 is 5? Yes. Equals minus 5. I'm going to take the square root of this and the square root of -5. And something should click, hopefully, in your brain when you see the square root of a negative number. You're going to end up with an I someplace because I squared equals the square root of -1 and I equals I squared equals -1. And I equals the square root of -1. So you're going to have an I in here someplace, a complex number. So I take the square root of this, and now I have x minus 4 equals the square root of -5, plus or minus. I like to rewrite this as the square root of -1 times 5. So x minus 4 equals, and this is I, square root of 5i plus or minus. So my answers for x will be +4 onto this. I have to have the square root at the end. So x equals 4 plus the square root of 5i, and x equals 4 minus the square root of 5i. Seems like a little challenging. What if you start with it looking like this, and you have to still complete the square? We're going to multiply it out first, so it looks kind of like the normal way we used to start to complete the squares. X squared minus 3 plus 3x minus x equals 2. So x squared, 3x minus x is 2x minus 3 equals 2. I need it to be a perfect square, so I'm going to take the 3 over and work with x squared plus 2x equals 5. Complete my square, I do half of, a different color, half of 2, and then square it equals 1. So I'm going to add 1 to that side. So now my perfect square is x plus 1 times x plus 1. So x plus 1 squared equals 6. I will take the square root of both sides. So x plus 1 equals square root of 6 plus or minus. Minus 1, minus 1. I have x equals minus 1 plus the square root of 6, and x equals minus 1 minus the square root of 6.